Hello everyone. In this video, we will see about safety monitoring, error detection and recovery. So before that, we'll see what is emergency stopping. Emergency stopping in a manufacturing setting necessitates notifying the operator on the shop floor, prompting them to promptly interrupt the ongoing process. To enhance safety and reliability, there is a growing need for automated mechanisms to safeguard both equipment and personnel within the workspace. This involves safety monitoring using various sensors like limit switches for movement detection, temperature sensors, pressure sensitive floor mats, light beams coupled with photosensitive sensors, and machine vision to identify and prevent unsafe conditions in the work cell. Next, what is safety monitoring? So it is a special case of error detection and recovery in which the malfunction involves a safety hazard. Decisions are required when the automated system sensors detect that a safety condition has developed that would be hazardous to the equipment or humans in the vicinity of the equipment. The purpose of the safety monitoring system is to detect the hazard and to take the most appropriate action to remove or reduce it. This may involve stopping the operation and alerting maintenance personnel to the condition, or it may involve a more complex set of actions to eliminate the safety problem. Next, coming to interlocks. Let's see what is interlocks. So interlocks in a robot work cell works as a sensor in a robot work cell for permitting the work cycle sequence to continue only after the preferred conditions are satisfied. It can be used to perform the following significant functions in a robot cell. It checks whether the work part is placed at the accurate location in the conveyor for allowing the robot to grasp it perfectly. It specifies the work part loaded is perfect for beginning the automatic machining cycle. Also, it helps in identifying when the work cycle has been finished for continuing the next machining cycle. And there are two important categories in the interlocks, such as input interlocks and output interlocks. So, input interlocks, it uses the signal that is sent from the robot cell's component to the work cell controller for specifying the conditions are satisfied and ready to begin the work cycle. And next, output interlocks, it uses a signal that is sent from the work cell controller to a component in the robot cell for indicating the machining center to begin the automatic work cycle. Next, the interlocks are implemented not only to prevent the work part from inaccurate starting, but also to protect the components in the work cell from damages. In addition, the interlock should consider the failures and irregularities that occur in the cell. If a malfunction takes place in a robot work cell, the application engineer must find out a technique to recognize the malfunction and should take a suitable solution. And subsequently, interlocks are used to obtain the series control as well as safety monitoring in both irregular and regular work cycles. Next, coming to what is error detection and recovery. So, the error detection and recovery is concerned with the decisions that must be made by the system in response to undesirable operating conditions. So, in the operation of any automated system, malfunctions and errors sometimes occur during the normal cycle of operations, for which some form of corrective action must be taken to restore the system. So the usual response to a system malfunction has been to call for human assistance. there is a growing trend in automation and robotics to enable the system itself to sense these malfunctions and to correct for them in some manner without human intervention. This sensing and correction is referred to as error detection and recovery, and it requires that a decision making capability be programmed into the system. So for this, use of appropriate sensors will detect error, recognize and classify it, and also it recover that one. So general classification of errors include random errors, systematic errors, and illegitimate errors. And specific recovery strategies are developed to deal with the specific type of error. This is error classification. So by implementing these strategies that can be employed by the robot to correct or compensate for the malfunction that has occurred. So error recovery strategies are adjustments at the end of the current cycle, adjustments during the current cycle, stop the process and invoke corrective algorithm, stop the process and call for help. We'll see one by one of this error recovery strategies. So first is adjustments at the end of the current cycle based on the error level. That is, if it has low level of urgency, robot program branches to a subroutine to make the required corrections. That is, for example, if a robot dropped a part, then logical action is to go for the next part. That is, after this, there is no serious error in this. Okay, so it go for the next part, then pick up that part, then come back to that main program to continue the process. Next is adjustments during the current cycle. If the error is serious one, action to be taken during the current cycle of operation. For example, machining of a oversized part. In this case, it invokes additional program to machine extra material at that time itself if the process is not stopped. Okay, it calls a special subroutine for corrective action. And next, the third recovery strategy is stop the process and invoke corrective algorithm. For example, in case of a tool failure, we have to change the tool and replace the damaged part. After that, the process resumes. So here, this error requires a process to be stopped. A subroutine is called to correct the error. Then the process resumes. And the last strategy is stop the process and call for help if the malfunction cannot be corrected by the robot. Okay, it requires human assistance to restart the system. For example, in case of hydraulic system breakdown, automatic recovery is not possible in this case. That time it requires human assistance to restore the system. So because of this unclassified error, no corrective algorithm is designed earlier. And so this is about the error detection and recovery strategies. Thank you.